Students, welcome back to our discussion on multi-stage vapor compression refrigeration system. So, in the last session, in the last lecture that we studied about a multi-stage compression with some simple intercoolers. Okay, so here now we are going to discuss a case where we are having multi-stage, or another term is compound compression method, where we are using 3 expansion valves and 3 compressors and 2 flash intercoolers. Okay, so the one thumb rule you can take will be the number of flash intercoolers will be one number less than the total number of compressors. So normally if there are 3 compressors in a system, there will be 2 flash intercoolers, or there will be 2 intercoolers. Okay, so the number of intercoolers or even the number of flash intercoolers will be 1 less than the total number of compressors. That you can take as the thumb rule. So normally in the university exams they will be asking to draw and represent the multi-stage vapor compression refrigeration system with say 3 compressors and 2 flash intercoolers, or say 4 compressors and 3 flash intercoolers, like that. Okay, so first of all let us look at the diagram. Okay, so starting with our most important step in our refrigeration system, that is evaporator or the refrigeration step 1 to 2, 1 here, 2 here. 1 to 2, it is our evaporator process, constant pressure heat absorption process. Okay, so 1 to 2 it is our constant pressure heat absorption process. We can represent in our pressure enthalpy diagram a horizontal line from 1 to 2. Okay, so at 2 the refrigerant is entering the first stage of compressor C1, okay, where it is undergoing isentropic compression from 2 to 3. So isentropic compression 2 to 3 can be represented as an inclined line in pressure enthalpy diagram. 2 to 3 isentropic compression process. Okay, then immediately after 3 the refrigerant is passing through a flash gas chamber. Already we have learned the working of a flash gas chamber. Flash gas chamber is nothing but a pressure vessel at an intermediate pressure where the vapor form and the liquid form of the refrigerant will be getting separated. Okay, and whatever vapor form of the refrigerant is getting collected inside the flash tank, it will be admitted to the nearest possible compressor. That is what is shown over here. Okay, so from 3 to 4 the refrigerant is passing through a flash gas chamber. So when it is passing through the flash gas chamber, a degree of coolness is provided, or some cooling effect is provided by this presence of this flash gas chamber. So this flash gas chamber will be acting as a intermediate cooler or intercooler. Okay, so as a result of that, from 3 to 4 we can represent this intercooling. Okay, actually 3 to 4 is a intercooling process, and this intercooling is provided by the presence of this flash gas chamber. Okay, so this flash gas chamber present at here will be acting as a intercooler for this 3 to 4 process. Okay, after this point 4, it is coming to the second level of compressor, that is C2, where it is where the refrigerant is undergoing a isentropic compression process from 4 to 5. So 4 to 5 will be a isentropic compression process or inclined line in a pressure enthalpy diagram. So immediately after 5, it is again the refrigerant is again passing through the second level of intercooler, or the second level of flash gas chamber or flash intercooler from 5 to 6. So we can represent that 5 to 6 as a horizontal line. This 5 to 6 is representing the intercooling action by the second level of flash gas chamber present over here. Okay, then followed by 6 to 7. 6 to 7, it is the third level of compression or the isentropic compression process. 6 to 7, So it can be represented as an inclined line or isentropic compression process in the pressure enthalpy diagram. Okay, then 7 to 8, our normal condenser process or heat exchanger process. 7 to 8, it is a condenser process or heat exchanger process. So 7 to 8, it is a constant pressure heat rejection happening at the condenser. So it will be a horizontal line in the pressure enthalpy diagram. Then immediately after 8, the refrigerant is passing through the expansion valve, the combination of expansion valve and the flash gas removal chamber. So in the last class, in the last session, we have discussed how this flash gas removal is working and how this expansion valve plus this flash gas chamber will be bringing down this will be bringing about this separation of the liquid form and vapor form of the refrigerant. Whatever liquid form of the refrigerant is remaining inside the flash gas chamber, that will be admitted to the next level of expansion valve and flash gas chamber, and finally proceeding to the evaporator. And whatever vapor form of the refrigerant is getting collected in the in this flash gas chamber, that will be admitted directly to the nearest possible compressor. Here in this when we are considering this flash gas chamber, the nearest possible the nearest compressor available will be the C3. So the flash gas getting formed at this flash gas chamber, that will be admitted directly to the C3 or the third level of compressor. And this process is shown over here from 8 to 9. From 8 to 9, it is a intermediate expansion process happening at the intermediate pressure of the flash gas chamber. Point 9 represents the intermediate pressure at which the flash gas chamber is situated, or this flash gas chamber, it is having a intermediate pressure, and that is represented as 0.9. So at this intermediate pressure, some vapor form of the refrigerant is removed from the liquid form of the refrigerant, and that is the duty of the flash gas chamber. And the removal of the vapor form or the flash gas of the refrigerant is represented by 9 to 6. Okay, this 0.6 represents the inlet of the compressor 3. So the whatever flash gas is getting formed, that is admitted to the nearest possible compressor, that is C3, and that process is shown as a dotted line from 9 to 6. This dotted line from 9 to 6 represents the flash gas removal, or the removal of the vapor form of the refrigerant from the flash gas chamber, and it is admitted to the entry point of the third compressor, that is 0.6. Okay, 0.6 is representing the entry point of the third compressor. Okay, then whatever liquid refrigerant is remaining inside this flash gas chamber, that will be admitted to the next levels and finally to the evaporator. Okay, so at 0.9 to 10. Okay, at 0.9 it is the intermediate pressure at which the flash gas chamber is working. From 9 to 10, it is representing the formation of liquid refrigerant inside the flash gas chamber. Okay, at this flash gas chamber, when after removing the vapor form, only the liquid form will be remaining inside, and the formation of that liquid form is represented as 9 to 10. 0.10 is coming on the saturated liquid line of this vapor dome. 9 to 10 is representing the formation of liquid refrigerant inside the flash gas chamber. Again, after 0.10, it is the refrigerant is again going and entering the next level of or next combination of expansion valve plus flash gas chamber. Okay, so 10 to 11, that is the process. So 0.11 is representing the intermediate pressure of the next or the second flash gas chamber available. So this flash gas chamber available between 11 and 12. Okay, 11 and 12, that is the this highlighted area of this flash gas chamber, that is situated at an intermediate pressure that is represented as point 11. Okay, so again at point 11 some flash gas removal is happening, and that whatever flash gas is removed, or whatever vapor form of the refrigerant is getting removed, that is admitted to the nearest possible compressor, that is point 2, sorry, that is the C2. Okay, the entry point of the compressor 2 is represented as point 4. So that is why the dotted line from 11 to 4, it is representing the flash gas removal from the second level of intercooler, or the flash gas intercooler. Then whatever liquid refrigerant is remaining inside the flash gas chamber, and the formation of liquid or the saturated liquid refrigerant inside the flash gas chamber, that is represented as 11 to 12. Okay, so 11 to 12 is representing this horizontal line. 11 to 12 is representing the formation of saturated liquid refrigerant remaining at the flash gas chamber. So point 12 is on the saturated liquid line of this flash gas of this vapor dome. Then 12 to 1, the 12 to 1, point 1 is the entry point of the evaporator or the freezer compartment. 12 to 1, it is our normal throttling valve or the throttling process. Again a vertical line from 12 to 1, and 1 to 2 we have already represented the evaporator process or the freezer compartment, and the cycle will continue. Okay, so even though this explanation took a little bit time, when you start drawing this pressure enthalpy diagram by considering this diagram, it will be very easy. So you should always practice drawing both these diagrams, then only you will understand this concept. So you draw when you draw the pressure enthalpy diagram, you will draw from 1 to 2, you understand what is happening there. 2 to 3, you understand what is happening there. 3 to 4, okay, step by step you draw each and every line in our pressure enthalpy diagram, then you will be learning it thoroughly. Okay, thank you. So, and also one more thing, in the last university exams, they were asking this question, that is draw and represent a multi-stage compression, multi-stage vapor compression refrigeration system with for example 4 expansion valves and 4 compressors and 3 flash intercoolers. So first of all you need to draw such a diagram like this, and you have to represent the pressure enthalpy diagram of that system. So thank you.